Hello and welcome to VMware SD-WAN with AWS CloudWAN Automation QuickStart. Here we're going to do an overview of what is CloudWAN, talk about the architecture topology, required files, and then move on to deployment workflow. What are some of the prereqs, all the way through the automation workflow, and then also the deletion and post requirements once you tear down the project. And then we'll touch on a little bit about the troubleshooting. So what is AWS CloudWAN? It basically allows you to build global networks in minutes, leveraging AWS's global backbone. You can connect VMware SD-WAN, deploy that into a transit VPC, and then that communicates via BGP over IPsec direct from those edges in a hub cluster to the CloudWAN components, so global network, core networking. To simplify all this, you can leverage automation, and that's part of the QuickStart program that we will show here. So what's the architecture? So the architecture built here is really a two-node SD-WAN deployment in a transit VPC. Across each node is in its own AZ, availability zone 1 and 2. These will build the VMware SD-WAN virtual edges will build the BGP over IPsec connectivity to the core network. With the automation, we're leveraging AWS Lambda for running the automation scripts, Amazon CloudWatch for logging, and then AWS's secrets manager, which allows to keep credentials safe and secure. So for the demo we'll show at the end of this, what is built out here is a enterprise with an existing branch already pre-configured, and then a deployment in AWS with 2 VPCs. Each VPC has its own single subnet. These subnets will be used to deploy a policy for segmentation. At the end of it all, the automation will build the transit VPC, deploy each of the edges and activate, and then plumb the BGP over IPsec into the core network. Then we'll show ping connectivity from each of these workstations that are belonging to a specific segment. First one here, global segment. Second one, the deployment segment. So just a little background, what's in the QuickStart project is 3 CloudFormation templates and 1 Lambda package. You have an entry point template that builds and applies the IAM policies, and then prepares for launching the Greenfield template that builds your VPC subnets, route tables, etc., and deploys that first SD-WAN edge. Secondly, we deploy the Brownfield into that existing VPC that we created with the Greenfield. This allows those edges to come up into the transit VPC, and then through API communication between the VCO and AWS, we pull the needful IP addresses, endpoints, so we can build the BGP over IPsec peering relationship. Just to discuss a little bit of the deployment workflow, these are prereqs, so you can go to the QuickStart project files here listed in GitHub. I'm going to show that it's also hosted on a portal, and it's very easy to launch just from a one-click perspective. You'll obviously need a enterprise account on the VCO, and then we have to have a couple basically configure a hub profile that needs to be existing before we deploy QuickStart. That hub profile will contain the 2 nodes that build that cluster for the SD-WAN deployment. We also going to have 2 segments already defined, one being the global segment. The other one we're calling a development segment. That's already been predefined. And then we have the 2 existing VPCs that will be connected once we launch the automation. One last note here is just to make sure that you have enough resources in the region. There is quotas. Typically, by default, that only allow you to deploy so many site-to-site VPNs, customer gateways, so on and so forth. So just ensure that you have enough resources available to deploy this. So here's going to be the launching page. We're going to take you through the demo. I will show how you launch this quick start automation. But basically, the entry point template comes up, and you would hit next, and then you configure the stack parameters. So some of the obvious here: the VCO configuration, username and password for the enterprise. The profile name, that's the profile that we already pre-configured. This is the second segment name. This is the one in addition to the global segment. In our case, we used development. And then some AWS specific configurations. One notable here is the S3 bucket name. So these files are already hosted in S3, so all the project files that I showed previously. But an additional bucket needs to be created so that a configuration JSON gets stored in that bucket. That configuration JSON is used to tear down these projects and clean up the resources. The only note here is that S3 bucket name has to be unique. And then we're going to select the subnet, each one for the global segment and the second one for the development segment. This configuration information here is by default because the project files are already hosted in US East 1. So nothing needs to change at this case. But if you decide to take the project files, make some modifications, and now you want to use those modified files, you can build your infrastructure in S3 and then copy those files in. You just need to change the corresponding name, region, and key prefix if that has been changed. So let's look at what the automation workflow is doing. So we have the entry point here. And so we create the stack, we fill in the parameters. From that point on, it's just kind of a wait while the automation proceeds. The first one here is to create the IAM policy rule and then build and execute the Lambda script. This also engages the logging to CloudWatch, so you can monitor the launch, and then it proceeds to creating the two edges, getting the activation keys, launching the greenfield template, configuring the first edge, creating the brownfield template, configuring the second edge. And then once we get the public IPs from both of those edges, we use that information to create the customer gateways and build the site-to-site VPNs. This then proceeds to create the VCO network services, which is used for the non-SD-WAN destination via edge. And then we move on to creating the VCO IPsec direct from the edge policies per edge and per segment. Lastly, we create the global network on the AWS side, core network, and then we attach the VPNs and the VPCs that we had previously configured. And then this is just an example of the file. Once everything's completed successfully, this file gets written out to that S3 bucket that I had mentioned before that needs to be unique, storing the configure information. So successful deployments, what you'll see is you'll get in the stacks under CloudFormation, you'll see that each one completed successfully. And then you can look at the cluster showing that it is up and active. From a logging perspective, under CloudWatch, you can go and look at the logs as it proceeds to execute. I've snipped this out because the execution time is about 10 minutes to run through the whole deployment. But what you'll see at the end is a status success if everything was successful in deployment. This is just an example of that JSON file, the config JSON that I mentioned before. In that unique S3 bucket. Basically, it just contains all the examples here: edge ID, name, your public subnet IDs, so on and so forth, VPN information, logical IDs, so on and so on. This is all information that's needed to configure and or destroy when you tear down your deployment. So Network Manager basically creates the global and the core networks with a policy. This policy JSON is already pre-configured for you. What this is showing is how we separate out the segments. So you have a global segment and a deployment development segment, and each one of those are then attached into your attachments as you see here. So when these VPNs and VPCs come online and go available, your segment here will be represented by the policy number. One last thing to note is on those two VPCs that were already pre-configured, even though they have been automatically attached in the core network, you still need to go to each VPC and update the route table to point to the core network. So in this example, I'm showing a quad 0 pointing to the core network that was already created. You'll need to do that for both VPCs. You can use an RFC 1918 or quad 0, just depending on what your workload's doing on the back end, and just ensure that you've considered what routing requirements are needed. And then from a branch profile perspective, you would want to make sure you go in and turn on Cloud VPN and select your branch hubs for each of the segments. So here I'm showing global segment, and I enable Cloud VPN, and then select the cluster that we had just brought up, and then do the same thing for the deployment segment, and then save those changes. This ensures that the branch will now connect to that transit VPC hub cluster. Once everything comes up, you'll see tunnel status go green. BGP peering is established here. And then from an end-to-end perspective, running a ping session from each of these workstations should, get a response back from each of the workloads. It's specific to each of those segments. So deployment segment talking to the deployment segment here, and global segment here talking to the global segment. Now we'll just quickly talk about deleting the deployment. All you need to do is go into the CloudFormation stacks and basically delete the root stack shown here. So when we deploy it in the demo, I call it my test. That goes and deploys the greenfield and the brownfield. Simply going to my test and selecting delete will delete these templates in order, brownfield first, greenfield second. So it cleans up all the VPCs and edges. And then there's some additional scripting that goes to the VCO and deletes the edges and network services. And this also can be viewed in the CloudWatch. So just a quick example of the delete workflow. So you delete the root stack. Here we pull that config file that I had mentioned before that was saved in that unique S3 bucket, and then go in and start to delete the brownfield stack, greenfield stack, delete the edges on the VCO. Again, this is all logged in CloudWatch. And then lastly, post-rec. So there is some things that don't get cleaned up. So just want to make note of that. So those VPCs that you had updated the route tables to point to the core network, you need to remove those routes, otherwise they'll show up as black holes. And the network manager console on the AWS side, you want to delete the VPC and VPN attachments. Once those are deleted, then you can delete the core network, and then lastly delete the global network. From the VPC console, you want to go in and just delete the site-to-site VPN and the customer gateways, which were created when those edges were deployed. Just note that deleting the attachments does take some time. So when you delete the VPC and VPN attachments, the site-to-site and customer gateways will not be able to be deleted at the same time. You have to wait till those attachments are deleted. Then you can go in and delete site-to-site VPNs and customer gateways. And then from the orchestrator perspective, just go in and delete the hub cluster that was created in the branch profile, and just clean up the branch profile, and then under the network services, the cluster configuration. And some notes on Troubleshooting, really two main areas to look at: the CloudFormation events and the CloudWatch logs. If deployment is successful, but still unable to ping the workloads, make sure that, a few things to check. VPCs have a route pointing to the core network for the workloads you're trying to reach. Security groups are allowing ICMP. If there's a branch in the cloud that each interface a segment, in this case, if you deployed a branch in AWS or in Azure or GCP, ensure that either source destination check is disabled in AWS or IP40 is enabled in Azure and GCP. And then lastly, obviously, just ensure that Cloud VPN is enabled. So this is the landing page that is hosted by AWS, sponsoring the VMware SD-WAN. And so additional information here goes on to how to get started, what's going to be built. We're going to go ahead and move into how to deploy. It'll take you through the steps here of what needs to be done to get this ready up and running. In our case, we have everything going. I will look at the VCO here just to give some insight to what is already pre-configured. So we already have an edge deployed in the branch. This is representative of this branch here. What we're going to build is this transit VPC, and we're going to attach all that via a direct BGP over IPsec into the core network. Some of the existing configuration that I had mentioned before, these are just the prereqs. We want a already predefined segment. In this case, we call it development. And under the profiles, we want to create an AWS Transit Hub profile. Do note that under the profiles for device configuration, you want to ensure that your interfaces are set up accordingly. In this case, I'm showing GE2. We went ahead and switched it to a routed port. And then GE3, we just left it as a routed port, but turned off the overlay. So routed port on GE2, and that's WAN overlay auto detect. And then GE3, we just went ahead and removed the WAN overlay. GE3 is really not going to be used because you're not going to be hosting workloads behind the edges, the cluster edges in that transit VPC, but this is just kind of best practice. Okay, at this point, let's go ahead and launch the QuickStart. As you can see here, the S3 URL is already provided for the entry point template. In my case, I'm going to change the region where I have available resources. I'm going to use US West 1, and then we're going to click Next. Okay, I'm going to give it just a simple name here. Now we need to get the VCO, fully qualified domain name. The username, this is already an existing enterprise account. Password. Now this is the hub profile name that we had pre-configured, so AWS Transit Hub Profile. And then the secondary segment that we're going to be using. Again, this was already pre-configured in the VCO. This is the S3 bucket name that needs to be unique. In my case, this is unique to my environment. So this is where we'll be storing the JSON config file. And then here we're going to select the subnets that we're going to use and assign per segment. So in my case, subnet child VPC 04 subnet's going to go to the global segment, and then child VPC 03 is going to go to the development segment that we have pre-configured. Select your key. And then again, as I mentioned previously, this doesn't need to be changed as we're already hosting the QuickStart files. The only time you would change this is if you've actually downloaded the files, pre-staged them, made some changes, for example, and you wanted to execute those files, then you would have to fill out the needful here. So I'll go to Next. All the rest of the default settings are fine. So Next. And then just an overview of what we've configured for parameters. And I'm just going to jump down to the end. Here, we just need to acknowledge that this is going to create an IAM role So we have specific permissions to launch this. And then we go create the stack. Okay, so at this point, we've launched that entry point template, and we called it my test. Here we've created that S3 bucket that's hosting the JSON config file. We're passing in the VCO credentials. We're setting up the IAM permissions. S3 bucket completed. Okay, the roles have been set up. Now we're building the Lambda, and we should be executing here in a second. Okay, now we've executed that quick start. So now Lambda has launched, and it is starting to do the automation, talking to the APIs on both the VCO and on AWS. We can track the progress here further by looking at the events. This is the first edge being deployed in the green field. If we go look under edges here, monitor, we now have 2 edges that have been configured. We've received their activation keys, and then the CloudFormation stacks will continue to create all the resources necessary to deploy. These 2 are being deployed here in US West 1. So now we can go look at CloudWatch, do a refresh. You can filter it, search for the name of your entry point. And here we started to log right out to CloudWatch. And as you see here, we're waiting for stack completion. I'm going to click on resume. So now you can see that the greenfield stack has completed. We've gotten some additional information that we need to continue to configure for the brownfield stack. At this point in time, the brownfield stack gets launched, and now we're waiting for the WAN links to come up on both of the edges. If you take a look at the CloudFormation stack, you can see that the first edge was created. Now we're creating the second brownfield, and then we will continue to wait for these edges to come up. Okay, at this point, we got the first public IP address for the first edge. Now we're just waiting for the public IP of the second edge. We're showing that both the stacks were completed. So both edges from AWS's perspective are done. Now we're just simply waiting for the edges to come up. Okay, now we've received the second public IP address from the second edge. This allows us to move forward and configure the customer gateways on AWS side and start to build the site-to-site VPN. Then we move forward to configure the enterprise services on the VCO side, one for each edge and each edge for each segment. And we continue down and we enable Edge Direct for each of those edges, and then we build the configure the global network, and now we're waiting for the core network to come up. Okay, now we have the core network is now available, and then we dump the configuration information. And a couple notables here. I'm going to go ahead and pause because the execution is completed, showing the success. Here we wrote up the config JSON to the bucket that we had configured in the CloudFormation stack parameters. If we go back to the CloudFormation stacks, you see they've all completed successfully. So here under Network Manager, here's where we created the global network. Then it created the core network. That's what we were waiting for to come up. And it creates these attachments. So you got the 4 VPN attachments and the 2 VPC attachments. Right now they're in a creating state. They will move to a pending network configuration and then go available. Once they become available, the site-to-site VPN tunnels should come up. This is an example of the policy that we created. Execution was successful. That's when the core network become available. And this is the example, again, of what the policy file looks like. And it's basically mapping the segments to your policy numbers that are represented under attachments. Okay, now we have all the states for all the attachments have now transitioned to available. We are now showing that the IPsec is up for each of the edges and for on a per segment basis. development and global. Go look at the configuration. We'll just take a look at one of the edges here under the global segment. And this was all pre-configured through the automation. So you have your non-SD-WAN via edge configuration, and then you have your BGP peering configuration. Now, last couple things that we need to do to ensure we have end-to-end connectivity. Let's quickly look at the diagram again. So again, we have the branch profile here. So I need to go into that profile and I need to enable Cloud VPN so that we join the hub cluster here. Then I need to go to each of the VPCs under the route table and point it to the core network. At this point, I'm running a ping session from each of the workloads here to the workloads here. Obviously, they're timing out since we have not configured the last remaining steps. So let's do that now. So under profiles, go to branch profile, Cloud VPN, enable branch to hub, edit the hub selection, and we're going to take the cluster. And we'll do that for the development segment as well. Okay, now we've updated the profile. Status is still up. We look at the ping sessions. As expected, they are still not responding since the last remaining step is to go and configure the route tables for each of those subnets. Here's we've associated the core network that was already deployed. Save the changes. And as you can see now, we're getting a ping response. So in summary, the QuickStart automation built the transit VPC, deployed the two edges, each edge in its own availability zone, built the core network, brought up the site-to-site VPN, plumbed the BGP over IPsec, and attached the site-to-site VPNs to the core network as well as the child VPCs here. Then we went to the branch profile, updated it to point to the hub profile here for connectivity, and then went to each VPC and put it in a route that points to the core network. Here we're showing the BGP is established up and we're receiving routes. Here we're showing the routes that are learned in the OFC. And that concludes this demo showing end-to-end connectivity, leveraging CloudWAN, AWS automation, VCO, SD-WAN deployments. I hope you found this useful. Thank you for watching.